moving on to question 2 now, we have a question here that's looking at goodness of fit for a distribution. So basically all we've got here is a spinner that's used for a game to give the following scores, so 1 through to 6, and these are the following probabilities. And then the spinner's spun 80 times, and the results are as follows. So we've got to test at the 10% level of significance whether or not the spinner is given the scores as it is designed to do. So, first off, what we should do is write our hypotheses. So, H0, so for one of these goodness of fit questions, the H0 is that it's working as intended, or it's giving the scores that it should do. So, the spinner works as intended. Works as intended. So what that means is that my H1 must be that the spinner does not work as intended. So the spinner does not work as intended. Okay, so that's just my hypotheses. That gets us off to the start with this question. Now what I can do is we have the observed values here. So this is what happens. It was spun 80 times. These are the observed values. So observed. Well, if we've got the observed values and we had a probability and we're told how many times it's spun, well, we can work out an expected number, right? So what I'm going to do is I'm going to set up a table. I've got my observed values. I've got my expected values here, and then what we'll do after is my observed values squared divided by my expected. Okay, so let's write in the observed ones first. So it was 15, 4, 12, 41, and 8. Now let's work out the expected. So to get the expected, I'm just going to do the probability times by 80. So 3 over 10 or 0.3 times 80, that'll just give me 24. And then do this for each probability, so 0.1 times 80, I'd get 8. This one would be 8 as well. 0.4, so that'd give me 32. And then finally this one will also be 8. So now, all I've got to do is square my observed values, so this is what I put them on top, and then divide it by my expected. So 225 divided by 24, 16 over 8. 144 over 8, 41 squared, so that's 1681 over 32, and then finally 64 over 8. Okay, so we're writing these down because it's going to be used for the formula to give us the test statistic. So we'll just do it up here. In fact, I'll do it in blue so it's a bit clearer. So remember, the formula here now would be the sum of the observed squared divided by the expected. So it's going to be the sum of the observed squared divided by the expected. And then we minus n off, minus n. Okay, and in this case, n is going to be 80. So n is equal to 80. So all I need to do now is work out the summation of this. Well, if we do that separately, divided by expected, that's just going to be 9.375. So obviously I've just put all these on my calculator. Plus 2, plus 18, plus 52.53125, plus 8. Okay, so I've kind of gone right into the question here. It's a bit messy, but hopefully you can still read this. So all I need to do now is add all these up, and what I'll get is 89.90625. And remember, n is 80, so my test statistic is going to be this value here, so 89.90625. That's a 0.625 minus 80. Put it on your calculator, and what you'll get is that this is 9.90625. Okay, so that's my test statistic. Now I need my critical value, but before I can get the critical value, we need a degrees of freedom. So DOF. Well, how many different values do we have? We've got 5, 1, 2, 3, 4, 5. So we've got 5 sets of values basically. So 5 How many constraints is there? Well, there's only one constraint, and that's that it's spun 8 times. So we take off the constraints, which is just 1. So 5 minus 1 gives me 4. So we know that the degrees of freedom are 4. So now I can just work out I can just get the critical value from the formula book, and it is a 10% test level of significance. So go to your formula book, and what you'll get is that the critical value is 7.779. Okay, just like we did with the previous question, question 1, we just compare the test statistic to the critical value, and because it's larger, again, we reject H0. So reject H0, evidence to suggest that the spinner does not work as intended. So we'll just write all that down. So let's have the spinner does not work as intended. Okay, and there we have it. So that's question 2 fully complete.